Okay, so we want to look at the basics of probability concept. We can get probability events, joint events, conditional probability, and decision trees. Those are some of the things that you should understand. So probability always will give us a chance, or shall always range between 0 and 1. So all the answers that you calculate probability, you just have to get an answer that is between 0 and what? And 1. If it is a fraction, then a numerator is supposed to be smaller than the denominator. That's what it means. So all the answers, never find a negative answer, never find an answer which is greater than what? 1. Okay?
1. Yes, please.
So what about impossible events? These, they have got the probability of 0, and the event that is sure to occur, the probability thereof is 1. Okay? Yeah. So if you're given a contingent table like this one, we're given the males that take statistics, people that take statistics, and those that don't take, male and female. Then when you sum at the first column, you have 106. That is the total sum of those guys taking statistics. And 279 is the total sum of those that do not take statistics. And when you add along this row, you have the total number of those people that are male, and the 210 is the total number of those that are female. And all the people in the class, they are 439. Did you get that?
Yes, please.
Yes. If you got that, then the question is, what is the probability of the males taking statistics? So the probability of males taking statistics will be the number of males that we have. There are how many? There are 84 divided by the total number of people in the class. There are 439, and we have 0.191 as the probability of male taking statistics. Got it?
Yes, I have.
So the probability of females taking statistics will be the total number of, will be the number of female taking statistics, which will be 76 out of what? All the people take in the class. If we want those that don't take statistics, you do the same thing. Then if we want to find out what is the probability that the person who was selected is male, male now, regardless of whether they're taking statistics or not, right? Regardless of that. So you get the total number of males, 229 divided by 439, and you have the probability of taking a male, regardless of what they are taking. Okay?
Yeah.
If you're interested in females that do not take statistics, we'll get 134 divided by 439, and then we'll have the probability thereof. Okay?
Okay.
That is the probability of female not taking statistics. So I think you have gotten the glimpse understanding of how we deal with the contingent table. Okay. So an event that is described by a single characteristic is said to be a simple event. Hello, are you saying something?
No, I'm here.
And an event described by two or more characteristics is said to be a joint event. For example, a day in January that is also a Wednesday, okay, from all days 2019. So we have a day in January that is also a Wednesday from all the days in 2019. This is joint probability. It's a joint event. Understand, right? It's a joint event. There are two characteristics of that event. Okay. Complement probability or complement events or events that are not part of the event are said to be a complementary probability. Take, for example, the probability of A happening plus the probability of A not happening, that is A complement, shall be equal to what? 1. When you sum all the probabilities, the answer is supposed to be 1. You pay attention to that?
Yes. I can't get what you're saying. Hello.
Oh,
Aaron, the line is breaking. I can't get you.
oh, are you able to hear me now?
Yes, I can.
Oh, okay. So I was just saying that you're given that the probability of an event A to happen to be 0.8, then the question is, what is the probability that A will not happen? Meaning that is A complement, right? You can find it
Yes.
by making probability of an event not to happen, which is probability of A complement, as the subject of the formula. So you say 1 minus what? 0.8. And that will give you the probability of an event not happening, which is basically the complement of the event. Okay?
Yes, please.
If you're given the probability that the event will not happen, which is a complement, then to find the probability of that event to happen, you just subtract. We say 1 minus the probability of an event not happening. That will give you the probability of an event.
I can't get you.
Hello, are you able to hear me?
I can hear you now.
Okay, I was saying the probability of an event to happen, okay, plus the probability of an event not happening is equal to 1. So you'll be just making each one, the one that you want the subject of the formula, and subtract the remaining from 1, and then you'll be surviving like that. Okay?
Mm-hmm.
Okay. So what about sample space is the collection of all the possible events. We call it actually the sample space. So in card game, you know card games, right? That card game, Njuka.
Yes.
Yes, there are 52 cards. I don't know if you played that game during your days. You didn't?
No, I never.
You were not doing life, right? We used to do that to break even at school when you're breaking, you do pa 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 pa, and you leave it. There are 52 cards in total anyway. So you can do the probability of selecting maybe a diamond, probability of selecting hearts, just like that. So out of the total number, you got that time?
Mm-hmm.
Yes. So basically, this is how you organize the event anyway, from the contingent tables. This is almost the same one as the one that you had, remember, previously, right? It's just the same one as the one that we had. So the probability of an event to happen plus the probability of an event not happening should be equal to 1. Okay, I'm looking for a practical example that we can use to do the contingent tables. Obviously, it's the same thing. I would know. Okay, mutually exclusive events. Okay, they cannot occur simultaneously. Their intersection is equal to 0. Okay, the mutually exclusive events, they don't occur at the same time. Like the rain, for example, it cannot rain and the rain at the same time. You can't do events at the same time. Like it's not just possible. Okay, did you get that?
Yes.
Those are called the mutually exclusive events. Okay, so now collectively exhaustive events. Collective exhaustive events. So what you find is that one of the events must occur, then the set of events covers the entire sample space. So if you're given an example, you randomly choose a day from the whole year of 2022. Okay, let's say A is a weekday and B is a weekend. So C is January and D is spring. So events A, B, and C are collectively exhaustive, but not mutually exclusive. Okay. A weekday can be in January or in spring. Events A and B are exhaustive and also mutually what? Exclusive for event A and B. They are mutually exclusive. It can't be a weekday and it can't be a weekend, right? You can
Mm-hmm.
have that's what we mean exclusive events that cannot occur at the same time. Is that okay?
Yes, sir.
Okay. By the way, I'm just selecting the things that you need. I'm not talking about everything. When I see that you will need this more, then I talk about it. Okay? This is what I
Okay.
just said already. The probability of an event to happen plus the probability of not an event to happen, it shall give us the total sample space. Anyways. Okay, now the additional rule says A union B, okay? Probability of A union B or A or B. By the way, the or means add, plus O is
Mm.
adding, and the union is adding still from the set. So it shall be given as the probability of A plus the probability of B minus the intersection. That is the probability of A intersection what? B. So that is the additional rule. It's just a rule. The intersection is 0 for mutually exclusive. I already said that for mutually exclusive events, they don't have an intersection. They do not happen at the same time. And therefore, since they don't have an intersection, the intersection part will be 0. So we just have for mutually exclusive events. Okay?
Okay, got it.
Okay. If I'm speaking so fast, you always have to remind me so that
I
I can
shall.
slow down. Yeah,
Mhm.
I have to do this for you, not for myself. That is very important. Doing it for the learner. Okay, okay. Conditional probability. This is now getting to be a little bit important.
Hello? Hello? Aaron, are you there? Hello? Hello?
Hello.
Hi, I couldn't hear you.
Okay. Hello. Are you able to hear me?
I can get you now.
Oh, okay. So I was saying conditional probability is the probability of one event to happen, to occur, given that another event has occurred. Okay.
Mhm.
So if you are
Yeah.
given the conditional probability of A given B, you read this as the conditional probability of A occurring given that B has already what occurred.
Okay.
That is very important. The probability of finding A given that B has already what been found. You understanding?
Please go through that again.
So the way how we read this one, we say this is the probability of an event A happening, given that B has already happened. So what we are trying to study under conditional probability, we are studying the probability or the likelihood of one event to happen, just because the other one has happened, like those related events. Okay. Given that now this is like this, then this will occur. Okay. For example, you are a student, you have written the exams, the final exams, the results are out. Then the question is that what is the probability that you will graduate, given that the results have what come out? Did you get that? One event has to happen, has to happen so that the other one can happen. So one event will have to precede the other event. Did you get that?
Yes.
So this is equal to the probability of A intersection B over the probability. The down one is always this one, the condition that you are given. That is your denominator. This is very important. You need to get this now, at least. If you didn't get this, get this one. So the probability of A, so we are asking to find the probability of A, given that this B is like this, and then it will be equal to the probability of the intersection between the two sets over the probability of B. Did you get that?
Yes, this is very confusing, but hopefully I'll grasp it when I go through the video.
I will repeat. It is always, I like it that I make things clear when I'm teaching, so that when someone is going through a video, it's not depending on a video. I'm saying there are two events that you have, right? Now, the way how these events are arranged, they are arranged in such a way that they don't happen really, they are at the same time. As they say, one event has to precede the other. Okay. One event proceeds, then the other one follows. Are you following, right? Hello?
Yes, I am.
Yeah, so the question is, what is the probability of finding this event given that this one has occurred? Okay. For example, let me just give you a very short example. I think there will be an example, but I can proceed. This is still fine. You have this, let's have this. This is the probability of students passing and failing. So let's have pass. Let's have male, so that you understand. Let's have male and what? And female, right? Pass and failed. Okay. We have the numbers here. Let me use the red marker a bit. So we have numbers. Let's have 30 here. And let's have some numbers, 45. And these are just imaginary numbers. I'm sure you are understanding. And 51 here. So then when you tot up these numbers, you have to sum up these, okay? Sum up for the males. This will be 79, right? When you sum.
Yes, 79.
When you sum, this will be 96. 96. Yes. This will be what? When you sum this will be 75, right? 75. This one will be 49 plus 1. 50, 0, 0, 100, right? Yes. When you add this is 170. This is 175, right?
Yes.
When you add all of them, you get 170. So this is what you put in here as 175. The total. You've seen that it's almost getting where we were, where we started from. So now the question is, given that, okay, listen, given that a student is male, what is the probability that a student failed? Did you get that?
You're not audible.
It's not audible.
I can get you
Can
now.
you, I was saying, given that a student is male, right? Given that a student is male,
Okay.
so already what you have is that a student is what? Is male. Are you following?
Yes,
I'm saying, given that the student is male, so what you already have is the student is male. What is the probability that the student failed? So we are looking for this for the probability of the student what failing, okay? Failing, given that the student is what is male. So this will be equal to the probability of failing intersection what? Male, right? Over the probability of what? All males, right? I said this one, the condition that was given is your, will be what? Will be your denominator. Did you get it? The probability, yes. So what is what is the probability of the intersection? Male intersection failing. What's the number? Where they intersect male and failing? It's 49, right?
Yes, 49.
Where they intersect, yes. Over the total number is 175. So this is the probability of failing given that the person is male. Did you get that?
So it's supposed to be over the probability of the total number of males, right?
The total number of all the people in the class, not male.
So it has to be the total number of all the people in the class. But I'm saying this one.
No, sorry. It's the total number of males. Yeah.
So
it's the total number of male. How many males do we have?
79.
They are 79, yeah. So male is supposed to be, yeah, okay. I've seen you're following. Then what, given that, now you listen to what you're giving. The question is again, given that the person failed, okay? Given that the person failed, what is the probability that they are male? You've seen the way how I've rephrased the same question. Given that the person what failed. So what you are given will be so fail. Then what is the probability that the person is male? You've seen the way how the probabilities are changing. This will be equal to the probability of male intersection fail divided by the probability of what fail. You get it, right? So failing will be the denominator. Have you seen? So male intersection fail is still 49, but the denominator is total failing, which is what? 100.
It's 100.
Have you seen the way how it is moving? This is what we mean by conditional probability. So first you get the condition, then you write what you are asking, then you follow. You see that intersection, that over this denominator, this will be a denominator of this. Is that okay? Hello?
Yes, I get you. Okay.
Are you fine now?
Yes, I'm fine.
Yeah, because you need to understand when I'm around. Sometimes you can't ask the video. Yes. So you have to get it from here. And so that the video should just be there to remind you. Okay?
Okay.
The example that you were given is that of the cars on a used car lot, 70% have air conditioning, and the 40% have GPS. 20% of the cars have both. Okay, so 20% have an intersection, that is 2. So the question is that what is the probability that a car has GPS? You're following, eh? What is the probability that a car has GPS given that it has what? Air conditioning is. Okay. So what you are given first is what you start with. What are you given? Air condition, isn't it?
Yes.
Then what is the probability that it has GPS? So this is your question. GPS. So you're looking for this probability. So it will be equal to the probability of GPS intersection what? AC, right? Divided
Yes.
by the probability of what?
Cause the probability of, hello?
Yes, I'm following.
So we're going to say it's the probability of GPS intersection air condition over the probability of the total number of cars.
Okay. So this, we'll get it now. Here, this one is always your denominator. Okay. The condition that you are given
It's
is
always
what
the
is
denominator.
the denominator. That is what I've said under condition.
Oh,
So
okay.
it is over the product, probability of AC. We got it?
Okay, I have it. Got it now.
So now, what is the probability of GPS intersection AC? It is 20%. That is what we're given. 0.20, right?
Yes.
The intersection is 0.20. 0.20 intersection what? Air condition, isn't it?
0.7.
Air condition, which is 70, 0.70. Then you divide those. That is your probability of finding of a car to having GPS, given that it has what? Air condition. Are you fine?
Yes, I'm fine.
Yeah, you're fine with conditional probability. I think you should be fine, and you're fine. You're okay. So this is what is there already. I think I've explained about this. So yeah, that's what is there. Okay.
Okay.
Any question?
No, I'm good.
So now, with a decision tree, how do you present the same condition on a decision tree? Check. The condition that you have is number one. Number one, a car can have air condition, right?
Mm-hmm.
And it cannot have. Then at the same time, the car can have air condition and it also has the GPS, right? So for GPS, a car can have GPS given that it has air condition, or it cannot have GPS given that it has air condition, right? Or at the same time, the car cannot have air condition, but it can have a what? GPS. I follow you. It's possible for a car to have GPS, but not having air condition. Hello.
Hello?
Hello?
Hi, I can get you.
Oh, okay. So this is what I'm saying. So this is what happens with conditional probability and decision trees. You are given two situations, right? Okay, let's take, for example, maybe I use my own example. That's when you get it clear fast. Let's say we have the probability that the person, there is a machine, right? Let's say there is a machine that is detecting, that they use a tester for HIV. Let's use a tester for HIV, okay? You're following the story, you know how it is.
Yes, I am.
So this tester for HIV, number one, it has the probability of error, okay? That simply means it can manage to detect someone who is HIV and AIDS and record that they are positive. You're following, eh?
Yes.
And at the same time, that is having correct results. At the same time, it can also sometimes make an error of making those who are not HIV and positive, who are HIV and positive, and record that they are free of the virus. Do you get it, right?
Yes.
Yes. And at the same time, what happens is that we have these people who are negative, right? This test can sometimes record that they are positive when they are negative. There is that probability. A person is negative,
Hello?
but is hello? A person is negative, right?
Uh-huh.
But the tester has said that the person is what? Positive.
Positive.
So this is what we have now. This is the same scenario that we have. So we have two things that happen. Number one, to start with, you can take the way how we make a decision tree. To start with, are you able to see the red marker?
Yes.
Yes. To start with, you can either be HIV positive or negative, right?
Mm.
That is to start with. Okay, you're positive or negative. Then, again, from these people who are positive, there is now again the probability of being caught or not being caught. It is possible that the person can be positive and then the tester writes that they are positive, meaning they are detected. Then it is possible for these people to be positive, but the tester writes that they are what? Negative, not detected. You're following, eh?
Yes, I am.
Then for these who are negative, it is possible that this tester can write that they are positive. Okay. And again, it is possible that these people who are negative, the tester can write that these guys are non-reactive, they are negative. Do you get it?
Yes, I do.
So you have to get this scenario. That's when you can get the tree diagram. So always there is the starting condition. There are two conditions that are given. So there is the first one that it starts, then the other ones branch or they come after. I've said conditional probability, one event has to happen, then the next one has to follow. So in this one, we have that a person to start with, he can either be positive or negative. Then later on, a person can be positive but detected or positive not detected, right? Then again, this
Yes.
person who is negative can either be positive again and detected or can be negative and detected to be negative, that's non-reactive, or negative, but the tester says that they are positive. That's an error. So this is an example of how we make it a decision tree. I just wanted to use this one so that you can get it. So with this one, to start with, a car can either have what? Air condition or not have. Get it? To start with, a car can either have air condition or not have air condition, right?
Yes.
Then these same cars now, the same car which has air condition, it can either have GPS or not have GPS. You're following, right?
Yes, I am.
And again, for this car that does not have air condition, it can either have GPS or not have GPS. That is what happens. That's how you get these probabilities, okay?
Yes.
So now you start with what is the probability of having some air conditioning? 70%, right? 70%, 0.70, which means the probability of not having will be 1 minus 0.7. You remember complement probability?
Yes.
The probability of having air
0.3.
conditioning. Yes. So that is how we get the 0.3. I'm showing you it's from complement probability. That one started. Then again, we are told that the probability of having GPS and being what? Being detected is 20%. Okay. It is 20%, which is 7/2. 0.2 over 7. That is the condition that we have gotten, 20% over 70. So 70%. that probability to get the other one, the one that that it doesn't have, just subtract that probability, this probability from 1 again. It will give you this one. Okay, you subtract it from 1. Then to get this one as well, you are given the first one, the conditional probability. Yeah, this is the probability of having AC intersection GPS. Then you subtract this condition from 1, and then you get 5. Okay. Are you okay? Like,
yes, I'm okay.
You've understood?
Yes, I have.
Okay. Like clearly understanding, not just having ideas. Like we want you to understand.
Let's go through it for the last time.
Okay. So now, check, eh? Maybe we start from here, where it starts from. Yeah, maybe that's when we get it. There's a probability of a person having AC, air condition, and GPS, which is 20, right? 20%.
Yes.
And the probability of having air condition and not having GPS is 0.50. Then the total because the total number of people who have air condition is 70, that is what we were told, right? We're told the total number of people who have got air condition is 70. Okay? So since they are 70, all right, for those for GPS, we are given 20, right? Then
Yes.
for not having GPS, we'll subtract from 70. Like you get this guy, when you add GPS plus not having GPS, they should be equal to the total. You get it, right? This
Yes, I do.
70% is the total. So you you subtract 0.70 minus 0.02, you get the probability of not having GPS, right? Then you have no AC, no air condition. Okay, for those who are not having air condition, we have 20% thereof. They don't have air condition. Like this intersection which you have here is for not having air condition but have GPS, which is 20%. You don't have air condition but have GPS, 20%. And here, what happens is that now you are looking for the probability of no GPS but have again no air condition. It's 0.1. The sum there of 0.3. The sum everything is totaling to 1. So we have almost all the probabilities now. So what we want to do when we're making a decision tree, number 1, here is your decision tree, right? A person can have a condition or not having a condition. What is the probability that the person has air condition? 0.7, right? And then obviously 0.3 is for not having what? No air condition. Then for these people who are not having air condition, they can branch into having GPS or no what? No GPS. You get. So even this side, GPS or no what? No GPS. Okay.
Yeah.
So let's start. There is a probability that the person.
Please excuse me for a moment. I'll be back.
Okay.
What is this? Change to 5 or 5. One is the compression. Then water dispenser from Charanto Vashtak. Material. Guys,
Arion, are you there? Hello.
Yeah, I'm around. Hello.
Okay, I am back. I've stolen
Welcome.
20 minutes of the time again.
You're welcome back. You're welcome back.
Yes, we can continue.
All right. So this is what I was just from talking about. Yeah, I said that you're given the probability of an event having air condition over the car having air condition 0.70, and then the probability of the car having air condition, okay, or the probability of a car given GPS having GPS, given that it has a air condition, okay, which is the one that we just calculated. We calculated for the probability that the car, this probability we were just calculating in the background. You seen it. The probability of a car having GPS, given that it already has what? AC here. We found that it is 0.2 over 0.7. Did you get that? Yes. So that's how you get this part. Yeah, that's where this is where the number comes from. Then to find this one, you just say 1 minus what? 0.2 over 0.70. You solve. You get it 0.5 over 0.7, like that. Okay?
Yes, please.
Yes. Then again, you ask yourself this root. Now you're done with the first tree. You come to this other tree. So to find the probability now that a car has GPS, okay, given that it doesn't have AC. Did you get it?
Yes.
The probability that a car has GPS, given that it has got no
AC.
no AC. So you have to solve for that. You have to solve for that. So this shall be equal to what? It shall be same as the GPS intersection what? AC over what? Or no AC, right? Or not AC, no AC. GPS intersection, no AC, right?
Come again, you're saying it's going to be GPS intersection AC over
No,
no AC.
intersection, no AC.
Intersection,
GPS,
no AC.
no AC, yeah. That's what you're looking for. Given that it doesn't have any, you're following this route now. Given that the car has no AC, what is the probability that it has GPS? So it is GPS given no AC, which will be the probability of GPS intersection no AC over no AC. You get it, right?
Yes.
Over the
So in this
probability
case,
of no.
so GPS intersection, no G, it's GPS intersection, no AC,
no
which is
AC.
0.2.
Yes, 0.20. It is 0.2 over what? What is AC? The probability of no AC, not AC. The denominator is no AC, right?
So no AC total, is it 0.3?
Yes. Yeah, no AC is 0.3. Yeah, 0.3. So your answer is 0.2 over 0.3. That is this same one, which is this one. This one, if you can see it.
Yes.
0.2 over 0.3. That's how you find. Then to find this one down, you just say 1 minus 0.2 over 0.3. Did you get it?
But you
I guess it's
430, 25, 44, checking my stay. Check my question. Mm-hmm. Mm-hmm. 25, 44. Mm-hmm. So it's 25, 44. A. So there's 25, 44. 44.
Karen, are you there? Hello? Hello?
Yeah. 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 Let's see. Mm. Mm. So what customer they the
Hmm?
Hello. Good afternoon, madam. No. Thank you. I'm on the line from my fancy. Yeah, yes, yes. You can imagine from that time it's when I've managed to find one. And it's only in Solwezi, so you can get it. And there's only one remaining one. Yes. What we can do is, when are you ready to make this payment? Because it depends on the payment. The payment is done.
Wow.
Did you want to buy the market yourself? What? Yeah, it's on promo for 28 months. It's on promo for 28, 200 months. I should be somewhere. Okay, what you can do, you need to come to the one. We open another that account. Are you in arrears or still running smooth? Or you finished? Or it's on cash or high purchase? High purchase. Okay, but the net on the best list, you think it can allow you to add amounts? The net on the best list, can it allow you to put the launches? Okay, no problem. What you do, you can come to the Wanika. Just come with the one that is basic and then we'll do everything and then today is what? Today is Wednesday. Yes, please. Okay. Okay. Sunday. Okay. Okay, no problem. You can come through on Sunday. Yes, please. Just ask for Andrew. Yeah, you can make payment from the one even from Cosmo. McKenna. Okay. Yeah. So what usually happens is you don't necessarily need to come in. You'll be just coming. Once we do this transaction, the next payment is what you do. you'll be just communicating with your credit team so that you just maybe send the money out of mobile money and then they send the receipt to you. Or you inform me, yeah, you inform me when you send the money, I pay there, I will get the receipt, I forward it to you. Yes, please, yeah. Okay, you're welcome. So I'll see you on Sunday then. Yes, great. Yes, please. How I wish if accounts and then I said good at so that maybe are you able, you don't have soft copies of your documents. Yeah, you can send for me on WhatsApp, because what we can usually do is maybe I can actually open the account, you send the deposit to the credit team, and then maybe on Sunday we just come through, just sign for me. Where is your workplace? Like, okay. Yeah, because what we can do, I can arrange and open everything today. Okay, no, next week. Because there's a third, yeah, next week, yes. You can get it next week. Yeah. So, no. Yes, yes. Okay, no problem. You're all right. You're welcome. You're welcome. I'll wait for the statements. I'll come and tell you the thing about person. But I forgot to permit. But it was recording, but so it wasn't recording. Alex. Moshe, ulipo? Niko mwana. Mama ni msalama kaina. Mwana sasa sakira uziwache kwa mbaba. Hapa ni sakira tena ukifichi. Oh.
Okay. Hello? Hello.
Okay.
Madam.
Okay, Nzakuze, if I find someone.
Hello?
Did you manage to speak to Kido?
Can you hear me? Hello? 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 I don't know you. Maybe your mic is mute. I can't hear you talk.
Okay.
Ouch. Hello. 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 Aaron.